Assalamualaikum and good day to our respected lecturer Dr. Farah Zahara binti Ismail and everyone. I am Sarah Emilia Kislina binti Muhammad Helmi, and today our group from the Faculty of Built Environment, University Technology Mara is proud to present our Engineering and Environmental Science Analysis titled Sustainable Adaptive Reuse of Heritage Building, Environmental and Building Services Analysis of the Perak Museum. Before we dive straight into our technical findings, allow me to formally introduce our project team. Along with myself, this comprehensive engineering study was successfully driven by my capable group members, Muhammad Hazim Hakimi bin Azmi and Muhammad Taufikul Hakim bin Rusi. Together, we undertook this rigorous fieldwork, data collection, stakeholder interviews and asset evaluation for this historic property. Also, we would like to extend our heartfelt gratitude and special appreciation to the management and staff of Perak Museum for providing us with the vital data and letting us conduct extensive observation. In particular, we are deeply indebted to Puan Nurul Azila binti Ghazali, the Assistant Curator, and Encik Muhammad Nazir bin Hussein, the Museum Assistant. They graciously sat down with us during our site visits in May 2026, granting us crucial insights into operational updates, system maintenance logs and heritage constraints, and many more. Okay, to kick things off, let's explore the baseline concept of our report. Heritage structure represent a nation's tangible and intangible history, creating a unique environmental personality that must be protected. However, maintaining these centuries-old buildings exactly as they were often leads to modern operational obsolescence and structural degradation. This is where the concept of adaptive reuse becomes vital. It explores the delicate space between total destruction and rigid recreation, giving an old site a new operational life cycle rather than locking it into a single moment in time. This technique solves land scarcity and integrates modern sustainable mechanical and environmental infrastructure while leaving the historic roots completely intact. Okay, to systematically execute our assessment, our group established three primary objectives. First is to throughout analyze the Perak Museum to pinpoint its exact indoor environmental quality and building service related gaps. Second, to evaluate the practical potential of adaptive reuse strategies that seamlessly integrate environmental parameters like thermal comfort, acoustic, lighting and ventilation with active building utility services. Third, to propose actionable, sustainable, green interventions that will optimize overall building performance, enhance visitor comfort, and significantly extend the structure's overall life cycle. Alright, let's step back into structural history for our case study asset. Established in Taiping back in 1883 under the British administration of Sir Hugh Law, the Perak Museum is celebrated as the pioneer and oldest museum in Malaysia. Originally built to collect local natural specimens and cultural artifacts, it stands as a testament to colonial era public architecture. Architecturally, the structure masterfully blends British colonial style with smart tropical passive design feature. It originally utilized massive 500mm thick masonry brick wall, soaring open timber ceilings, expansive timber windows, wide perimeter verandas. These elements work together to absorb heat through thermal mass and drive state effect cross ventilation. However, as you can see from our technical floor plans and current gallery layouts, modern preservation requirements and artifact security rules have fundamentally sealed off these passive avenues. This creates major deep-seated environmental and service challenge that our group will now systematically unpack.
I will continue my presentation with environmental analysis at Perak Museum. To begin our environmental analysis, first we look at the overall performance of the Perak Museum by balancing its modern need with strict heritage conservation requirements. So, in this topic, we would like to analyze four main components, which is thermal comfort, ventilation and condition, lighting performance, and acoustic performance. First thing we would like to share about is thermal comfort, which is in its original 1883 design. The building was remarkably well suited for its climate. It utilized thick brick walls of approximately 500 mm and high timber ceilings to support passive cooling. At that time, the museum was reliant entirely on natural ventilation and daylight to maintain indoor comfort. However, the current environmental condition has changed significantly to meet conservation requirements, which is the original timber window have been sealed, which has severely reduced airflow and causes heat to accumulate within the structure. Because of this, the museum now relies almost entirely on mechanical air conditioning, which is this shift has led to several key issues. We see high heat gain and increased cooling demand. We estimate indoor condition it's already reached temperature at 20 Celsius or until 30 Celsius and a high relative humidity of 79 until 18%. Next, we're looking closer at ventilation. The performance of natural airflow has been implemented because of those sealed windows, which is mechanical air conditioning is now the primary method for moving air, but the existing ventilation openings are simply insufficient for effective airflow throughout the exhibition space. This has resulted in poor air circulation in enclosed galleries and stagnant air condition. There is also a significant concern regarding indoor air quality, especially the potential for musty outdoors during high visitor occupancy. Quantitatively, the estimated air change rate is below 0.5, which is far lower than the recommendation, which is 1.0 until 1.5 air change per hour. Before we move to the next person, I would like to evaluate the sensory environment, starting with the lighting. Due to the sealed windows, there is very limited daylight penetration, which is leading a high dependency on artificial sources like T8 fluorescent lamp and LED red lights. So this creates more uneven lighting distribution and causes problematic glare from the polished tile flooring. Furthermore, low color rendering light also affects how visitors perceive the artifacts. Next, I would like to turn into the acoustics, which is the exhibition space are dominated by hard reflective surface, such as tile floors and plaster walls. This material causes excessive sound reflection and echoes, which reduces speech clarity when the museum is busy. We also found that external traffic lights noise easily penetrates the building further, that causing impacting acoustic comfort. So thank you for my slide.
Thank you for Tofiko, my friends. So next I will continue the presentation for the water supply system and drainage and wastewater system. So in water supply system, we have three components, which is analysis, problems, and solutions. So for the analysis, is the building has built in 1883, which is have aging water pipes and leakage and unstable pressure. So the problem is the pipe is leakage, inconsistent water pressure, water wastage, and high humidity. museum have under the Jabatan Warisan, so it cannot change anything to the building. So to maintain the Warisan building, so the solution is upgrade piping system, water saving features, and regular maintenance. So I will continue another 2 points, which is electrical system, communication, and smart system. So we have 3 components: analysis, problems, and solution. For the analysis is aging electrical system and upgrade required. For the problems is fire risk, short circuits, high energy use, and power interruption. For avoid all the problems, we visit the building. The workers have told us about they have renew all the wirings, new wirings to maintain to avoid the problem. So the second is communication and smart system. That have 2 components: analysis and solution. For the analysis is smart technology improve operation and better visitor experience. We have to enhance the visitor experience and safety. So for the solution is IoT monitoring, interactive display, smart CCTV, strong Wi-Fi, and fire alarm system. In the Museum Perak, they have a fire alarm system to fire extinguisher and glass alarm. And for your information, they have a newly smart CCTV, latest CCTV, to make sure they protect our collection. We have many technical specifications. For the first is protect heritage building structure, preserve valuable museum artifacts, improve occupant safety and security, reduce water and energy consumption, lower long-term maintenance costs, increase system reliability, support preventive maintenance, enable real-time monitoring, enhance operational efficiency, comply with sustainable building practices, improve visitor comfort and experience, and extend building service lifespan. So we have 2 benefits about the operational and technical. So for the operational is improve visitor safety, better museum operation, lower maintenance costs, energy and water savings, and sustainable management. So for the technical is increase system reliability, real-time monitoring, preventive maintenance, longer service life, and heritage conservation. Overall is technical justification is about the justification about the buildings or the system technically for the visitor time operation, cost, and the savings of the energy and water. So the buildings or the management have control the operational, control the cost savings to sustain the buildings to all the visitors for the long term use for visitors.
In conclusion, our technical and environmental assessment shows that while the Perak Museum faces serious microclimate and utilities challenges due to its history, age, and the strict limits of the Natural Heritage Act, abandoning or ignoring this system is not an option. Adaptive reuse acts as our essential modern bridge by introducing non-invasive eco-friendly improvements such as a real-time IoT climate tracking, energy-efficient LED upgrades with high color fidelity, rooftop solar integration and hidden sections, and high-capacity drainage layouts. We can completely transform the museum into a highly functioning eco-friendly site. Ultimately, our purpose sustainable smart heritage museum concept prove that we can future-proof our historic spaces, guarantee artifact safety and ensure visitor comfort without erasing a single piece of our natural heritage or history identity. Thank you very much for your time and attention. I will now open up the floor for any questions or feedback from Dr. Farah or our peers.